charger first.
Recording is on.
Okay. 오케이 맞다. 오, 오케이 맞다. 얘 뜨게 줄까요? 얘 뜨게 줄까요? Là cái con này. 오케이입니다.
Now we can start.
Okay.
Which is just now we've learned in the lecture part, the theory. Now we practice. We'll start from the first example, which we've considered in our lecture. We saw this example, if you remember. We've calculated this using theorem 1. Like you may see here, which is limit x, y tends to 0 and 1. Instead of x with 0, instead of y with 1, 0 times 1, 0 squared times 1, plus 5 times 0 times y minus, no, 0 times 1 cubed. And we've calculated this, we got -3. And the second part, when x, y tends to 3 and -4, we've calculated this expression, we got the answer, which is 5. Now we'll move to real exercises and try to solve some exercise after this one, which is example 2. And we'll also consider this one. If it's hard to calculate this limit, or if it's not possible with just simply plugging in 0 instead of x and instead of y, so we need to rationalize the expression or simplify. In this case, we've multiplied both parts with the positive one of this one, x plus square root of y. And this one is also multiplied. And we also call this one in Uzbek qo'shmasiga ko'paytirib yuboramiz deymiz. Mana bu o'z osti x minus o'z osti y ni qo'shmasi o'z osti x plus o'z osti y bo'ladi. So square root of x plus square root of y. So this fraction is extended. Now here from there I can take this x and this x outside of parenthesis. I'll get x minus y. Parenthesis square root of x plus square root of y. And here these are square root of x minus square root of y, and then it's positive. It will give us x minus y. So these two expressions are similar to each other. This one gone with that one. So we got x times square root of x plus square root of y. And the answer we got 0. We saw this example in the theory, in the lecture part. And now another example. We need to find the limit if it exists. If it exists. Let's try to plug in numbers. Instead of x, write down 0. Instead of y, write down 0. So I will get 4 times 0 squared over, sorry. And 0 squared plus 0 squared. So this will be 0 over 0. I think it's undefined. So if the limit exists, x, y approaches 0 and 0, the value of the limit must be 0. So we have a figure to explain this exercise here. With this figure, the surface graph shows the limit of the function in example 3 must be 0 if it exists. When x and y tends to 0, x and y. So x is this axis, this one is x-axis in our case, and this is y-axis. And x, y tends to 0. It's that point. Both are 0 in this point.
Yes.
And when the x and y tends to 0, the picture x, y from here tends to that part, or from here tends to that part. From all the parts of this surface, the value of the function tends to which number? 0. Because this function is provided from that point, from the origin. Mana shu shaklga qaraydigan bo'lsak, bizda demak x ligimiz 0 ga intilyapti deyapti. Bu 0 nuqta, markazdagi nuqta, A nuqta deyilardi oldin. Demak 0 nuqta deyapti. Endi bunga intilganda mana shu grafikimizga qaraymiz. Ko'rsatilgan mana shu tekstli yoki mana shu sohaga. Buni ham demak x y 0 ga intilganda hamma tomondan mana shu 0 ga intilyapti. Chunki mana shu 0 nuqtadan o'tgan ekan bu funksiya. Agar limit mavjud bo'lsa, u 0 bo'lishi kerak. Bo'lmasa limit yo'q. Here it says about that one. So if the limit does exist as x, y approach 0 and 0, the value of the limit must be 0. Agar limit mavjud bo'lsa, demak u 0 bo'ladi. Bo'lmasa limit. This is like explained with the definition in the first one, like this limit exists if there is epsilon positive and these expressions are like wholes from that one. Let's say we have epsilon positive and it's arbitrary number. We want to find a delta positive such that this expression, this is the function. It was f of xy minus L. It was like this. If you remember, according to the definition. So f of xy is this fraction. L is 0. Epsilon is epsilon itself. Whenever this expression is 0, smaller than square root of x minus x0 squared plus xy minus y0 squared. It should be between delta and 0. Or from the first one, from this one, we can find this expression. Because this expression negative minus 0 is itself, and this one is x squared, y squared again. They are positive. 4 is also positive, but we cannot say about x. So we can drop this absolute sign. Model ishoralarni tashlab yuboramiz, but x da qoldiramiz. Chunki qolgani musbat ekan, ko'rib turibdi. And it's smaller than epsilon. This remains the same. This expression remains the same. We'll go further. Y squared is smaller than or equal to x squared plus y squared. This one. Why? Because y squared is equal to y squared, but x squared. If it's a positive number, it doesn't matter. It's small or bigger. This part will be greater than, or maybe it's equal when x is 0. So this is, it's easy to see this one, right? Bu tushunarli mana shu joyi. Y kvadrat x kvadrat plus y kvadratdan kichkina deyapmiz. Chunki bizda y kvadratlar o'zi bir-biriga teng bo'ladi. Agar y kvadratga x kvadrat degan qanaqadir miqdorni qo'shsak, u y kvadrat o'zidan katta bo'ladi. Agar u miqdorimiz 0 bo'lsa, teng bo'lib qoladi. From this one, we have that this expression, which is our function, smaller than or equals to 4 absolute value of x. So using this expression, we can cancel them. Y squared, x squared plus y squared. Like this, and if they cancel, we'll get 4 absolute value of x, and it will be equal to each other. Or in other case, agar qisqartirib yuboramiz deb o'ylasak ham, mana shunda ikkalasi teng bo'lib qoladi, mana bu ikkala tomon. Agar qisqarmaydigan bo'lsa, tepadagi y kvadrat kichkina son, mana bu qisqaradi katta son. Demak, bu qismi mana bu 4 modul ichida x dan albatta kichkina bo'ladi bu holatda. Chunki 4 modul ichida x da kichikroq sonni ko'paytiryapmiz. Birdan kichik ko'paytirsak, kichayib ketadi. Agar buni qisqartirib yuborganimizda ham teng bo'lib qoladi. Demak, mana bu ifoda ham to'g'ri. And from here, like the square root of x squared, the absolute value of x is equals to this one. Chunki ildiz ostida x kvadratdan ildiz chiqarsak, modul ichida x chiqadi. Musbat chiqishi kerak doim. Bundan mana bunga qaytyapmiz. And this expression is smaller than this one. 4 square root of x squared plus y squared. And we know this. So if we choose delta equals to epsilon over 4 and let this expression, square root of x squared plus y squared, between 0 and 4 delta, because we have 4 here, and the delta will be equal to epsilon over 4 as here, and we get these two 4's are gone, and it's equal to epsilon. So it follows from the definition that this limit exists and it's 0. If sometimes it's hard to calculate the limit, we can use this definition and these steps to show that the limit exists and its value. And one more example. If f of xy equals to y over x, does limit of xy when xy tends to 0 and 0 f of xy exists? So this question says puts the similar problem to us, like to show the limit, if this limit exists or not. The domain of f does not include the y-axis, so we do not consider any points xy where x equals to 0 in the approach toward the origin. Along the x-axis, the value of the function is f of x and 0 becomes 0 for all x is not equal to 0. So if the limit does exist as xy tends to 0, the value of the limit must be 0. On the other hand, along the line y equals to x, the value of the function is f of x, x equals to xx, which is 1, for all x is not equals to 1. There is the function f approaches the value 1 along the line y equals to x. This means that for every disk of radius d centered at 0, 0, the disk will contain points x and 0 on the x-axis, where the value of the function is 0, and also points x along the line y equals to x, where the value of the function is 1. So no matter how small we choose delta as the rate, it should be delta, not d. It's the delta. The radius of this in figure, there will be points within the disk for which the function values differ by 1. This is number 1. Therefore, the limit cannot exist because we can take epsilon to be any number less than 1. In the limit definition, and deny that L equals to 0 or 1, or any other real number, the limit does not exist because we have different limit values along different paths approaching the point 0 and 0. The limit does not exist. Ma'ruzada ko'rganimizda ikki tomondan yaqinlashganda limiti bir xil chiqmasa, demak unaqa limit mavjud emas dedik. Bir o'zgaruvchilik funksiyada o'ng tomondan chap tomondan degani bo'lardi. Ko'p o'zgaruvchilik funksiyada shunga o'xshagan deb qoidani ko'rdik. Mana shu qoidadan kelib chiqib limit mavjud emas degan so'zni aytyapti. 4-misolga. Now we have to calculate some simple exercises. The exercise number 1. Find the limit. So this one, you have to find this limit. Limit xy tends to 0, 0, 3x squared minus y squared plus 5 over x squared plus y squared plus 2. Okay, try to calculate this one by your own, and then I'll try to help you all. We'll try to get this together.
Now I will do it.
Okay.
Thank you. It first one is 5/2.
Okay, that's correct. Now try next exercise. Second, third, and fourth. I'll try to calculate first one here.
Second. Okay. Mm-hmm. I forgot how to solve third one. I forgot the
Third
formula.
one.
I think the third. Yeah.
Here we have to plug in instead of x the number 0 and instead of y ln 3.
Yes.
E to the 0 minus ln 3 will be equal to e to the ln 3. Ln. What is ln itself?
Ln
Natural
2.
logarithm, right? ln, just the ln. What
Yeah.
does it mean, ln? It's natural logarithm.
Uh-huh.
It's natural logarithm. Okay, we can write here ln. So, sticky. ln 2 equals to, for example, s. So what does it mean? E to the x
Repeat,
equals to
please.
2, right?
Yeah.
ln 2 equals to x. It means the x's power of e equals to number 2. E to the x equals to number 2. It means this one. So we have to use this expression. And the answer will be 2.
2.
Right? Because we also have this formula a to the log ab
2.
will be b. We also have this expression. So we have e ln. There is another e and another 2. Using that formula,
Okay.
this is maybe in the logarithm theorem, we can calculate this number 3. Did you get it? Hello?
Okay. I got it. I will do for. Eshitilyaptimi domla ovozim?
Endi eshitilyapti. Esladingizmi, mana shunaqa qoida bor edi, mana shu bo'yicha hisoblasa bo'ladi. So the exercise 4 equals to, instead of x, we have to write 1/27, okay, cosine cube root of 1/27 times, instead of y, we have to write pi cube cosine cube root of pi cube over 27.
X 1 taqsim 27 mi?
X 1 taqsim 27, y pi kub. Ovozingiz yaxshi kelmayapti.
Spita aytdimi? Internetim ishlaydi.
Izofiy taqsim
Ha. Men o'y anaqa kosinus
yo'q, izofiy
taqsim 3 gacha keladi. Keyin internetim qattiq qoldi.
1/2.
Asl men kosinus pi taqsim 3 gacha keladimi? Ha.
Ammo to'g'ri ishlabsiz, pi taqsim 3 gacha kelganmisiz. Kosinus pi taqsim 3 da 1/2 mi?
Ha. Internetim ishlamay qolyapti. Shunga to'xtab mana bo'lyapti-da. Ko'rinib ko'rinmay qoladi internetim. Shunga kelgan.
Yo bo'ldi, nima? Hijolat bo'lmay o'zi internet hammada shunaqa. Hozir nima emas. Keyingi misollarga o'tsak bo'ladi unaqada. So we have some more exercises. In this page, it asks to find the limits in exercises by rewriting the fractions first. we have to rewrite the fraction first. Rewrite, because we cannot solve this directly. We can't solve this directly. First, we'll need to rewrite it. For example, the first one says x squared minus 2xy plus y squared over x minus y. So x tends to 1, y tends to 1. 1 minus 1 is 0. So it's not possible to find the limit directly. First, okay, try to rewrite first and then calculate limit.
Okay. This our and 1/1 the x is 1. Then we have to write again x squared x2 xy plus y and then over x minus 12 x minus 7 plus
I'll try to show the first one. Equals to the upper part will give us x. Oh, sorry, I forgot the word limit. Limit. X minus y squared over x minus y. Again, and limit xy tends to 1 and 1. X minus 1. This gives us 1 minus 1, which is 0.
answer is 0.
And the
Yes,
axis, yeah,
Madam,
the first one answer is 0. That's correct. That's correct.
Okay.
For the second one, x is not equal to -4. X is not equal to x squared.
Yeah. Langsung yang kurang x over 1 cancel 1 over minus 4 plus 4 x squared and
X squared outside of parentheses, y plus 4 minus x, y plus 4. Y plus 4 is here.
one over 12. Answer is 1/12.
Which one?
Second one. The answer
Second one.
is 1/12 or yes.
Okay, look at my example. Where did I have a mistake?
Because
Where I did a mistake?
1/x² minus x.
It is correct that 1/x² minus x.
I think yes.
But I can plug in 1.
There
I can't plug in
write
1
an
yet.
x not equal to -4 and the x not equal to x power 2 there. X².
Yeah, that's correct.
Qayerda x deyapti, to'g'rimi?
Ha, shunday.
Keyingisi x teng emas x² ga deyapti, to'g'rimi?
Ha, shunday bo'lyapti hozir.
Okay. Endi hozir bu yerda birni b-ga qo'yadigan bo'lsak, x bo'lib qolyapti. Anaqa qolib ketdi-yu, x ga 1 bo'lsa,
Yo, x
qayerdadir xato
2 ga 4 ga xato bor ekan, mana. Bu yoqdan olgandim misolda. X 2 ga y -4 ga intilish kerak ekan bu yerda. 1 ga emas ekan.
o'shida xato chiqdi dedim-da men ham o'sha.
Ha,
o'shanga
bo'lish kerak ekan.
ha, 1 emas edi deyotganimda, to'g'ri kelmayapti-yu deyotgandim. Qatib qolsa
Ikki ekan, demak 2 ni qo'ysak 1
Kesmadi
taqsim 4 minus
shekilli.
1 taqsim 2 ekan.
Ha,
Prezentatsiyada yozganda xato ekan, to'g'rilab qo'yish kerak ekan.
2 bo'lish kerak edi-da.
Shunda to'g'ri bo'lardi.
Bu yoqda kelgan 2 bo'lsa, 1 taqsim 2.
Yeah, that's correct. Ha, men eshitmay qolgan bo'lmasa siz aytganingizni.
Uchinchisimi endi?
Ha, uchinchisini ham ishlasa bo'ladi.
Ha. O'zi ovozim ham kelgan yetib boryapti sizga domla. Anchadan kelgan.
Ha, shunaqa shekilli bo'lmasa. Okay, exercise 3, limit.
Ovozim kelgan yetib boryapti ekan.
And this one is also 2x minus 2. plus 2. So they're gone, and it's equals to limit xy tends to 2 and 0, 1 over 2x minus y plus 2. If I plug in 2 here, 2 times 2 is 4, 4 minus 0 is 4, and 2 is 1 over 4. Have you done with the third one?
Not yet.
Okay.
Yes, I did. I have done.
Okay. That's right. What is the answer?
1 over 4.
Is it 1 over? Yeah, that's correct. That's correct.
Okay.
There is exercise 4, and there are some more limits with 3 variables.
Mm-hmm.
And there are some exercises to check for continuity of the functions. So let us move to the limits with 3 variables. The first example says on page 13, limit p tends to 1, 3, 4, which is 1 is for x here, 3 is for y, 4 is for that.
Mm-hmm.
And we have to calculate this limit. So just plug in. Plug in this number instead of this variable, instead of x, instead of y and z.
Okay.
And get the common denominator, which will be 12.
Yes, 19 over 12. First one is correct.
Yeah. Yeah, it's correct. And second and third exercise, you have to solve like this. Now, I will move to the next page for continuity. At what points x, y in the plane are the functions exercise continuous? At what points x, y in the plane are the functions in exercises continuous? The first question says f of xy function is sine x plus y. So do you know the sine function?
I can't remember.
Yeah, the sine function is continuous everywhere because according to its graph, if you remember, it had this kind of graph. Sorry, this is the graph of cosine. Like this. It was continuous everywhere in the plane. It doesn't matter to its argument, here x and y. The first function continues
It's continuous.
everywhere
Okay.
in the plane. In the plane. The second function, f of xy equals to x plus y or x minus y. But in this case, we have to avoid from the zero on denominator. When this expression becomes zero, x minus y equals to zero. So x equals to y. Except this point. The second function is not continuous.
It's not continuous.
At points when x equals to y. When x equals to y, the second function is not continuous because when x is 2 and y is 2, 2 minus 2 becomes 0, we divide by 0. Or maybe both of them like negative 7. So their difference becomes 0. We cannot divide by 0 again. So it's everywhere except when x and y equals to each. And the third one says g of xy equals to sine 1 over xy. It's similar with the first and second exercise because we have sine and also fraction. So we know sine function is continuous everywhere, but we cannot say about this expression in the argument of the sine. So 1 over x, 1 over x, this is a fraction, so its denominator should not be equal to 0, or this is also like should not be equal to.
Yes.
And when this becomes 0, when x equals to 0, when y equals to 0, only in this case, the denominator becomes 0. We can say all points are everywhere except when x and y both are equal to 0. Everywhere in the plane. Except x equals to 0 and y equals to 0. If one of them equals to 0 is also point of discontinuity. They should not be equal to 0, x or x and y. X should not be equal to 0 and y should not be equal to 0. In the third case, g of xy. So we have to calculate this denominator. We have to find its zeros if it exists. X squared plus, or not plus, sorry, minus 3x plus 2 equals to 0. We have to calculate this quadratic function. So can we find its zeros? So x1 equals to how much? Number 2, x2 equals to number 1. So their sum becomes 3 positive. Their multiplication becomes number 2. Okay, that's correct.
Yeah.
At this point, this function's denominator becomes 0. So we can say the function is continuous everywhere in the plane except x equals to 2 and or maybe x equals to 1 except these points. The function is continuous everywhere except these points. Okay, move further. At what point x, y, z increase are functions in exercise continuous? It says in space because now we have three variables x, y, and z. It was plain when we had two variables x and y, and it was number line when we had just one variable, which was x. The first function. What do you think about this one, Zakir Khan?
Independent function in exercise continuous. I think continuous because we have x plus 2, x squared plus y square and minus 2z and square. I think it's continuous.
Yeah, this function is continuous everywhere in the space.
Yeah.
Because we don't have fraction here or square root or any other thing.
Yes.
Everywhere in the space.
Second,
How
I
about
think
the
second
next one?
is also
Then
it's I think also continuous because answer is x y z.
no, it's not the answer. There is ln, which is natural logarithm.
ln.
Natural logarithm.
Yes.
It means, yeah, ln. It means some power of the number e is x, y, z. So
Yes.
we had the number e, and it's some power, for example, x equal, not x. I don't need double x here. It's power, let me say, like omega equals to x, y, z. So e is a positive number. E approximately equals to 2.71 and etc. And its power when, let me say, x is -1, -1, then 5. So this becomes -5. E to the omega equals to -50. Do you agree with this? Can you find omega?
Omega. Omega is -15.
No, it can't be minus because E is itself positive number. It will never become negative if you find its any power. E o'zi musbat son, uni hech qaysi darajasi manfiy son qilib qo'ymaydi uni. 0 ga yaqin bo'lishi mumkin, 1 bo'lishi mumkin. Lekin hech qachon manfiy bo'lmaydi.
Tushunarli.
So this function becomes continuous, will be continuous. Second one. When x, y, z multiplication is positive. If this multiplication is positive, the function f of x, y, z, which is ln x times y times z, called continuous. In other cases, no, it's not continuous. And exercise 3, h, the function h, x, y, z, equals to x, y times sine 1 over z. Okay, try to find the answer for this one.
X and Y will be continuous, but Z I think not, because Z in the fraction 1 over that.
Okay.
Am I right?
Yeah, z is in the fraction. It's on denominator. So
Yes.
z should be or should not be?
Can't be continuous. It should not be 0.
Yeah, should not be 0. The function will be continuous when z is not equal to 0.
Mm-hmm. Yes.
Z is not equals to 0. In other cases, it's continuous.
Mm-hmm.
How about the exercise 4?
I think it's continuous because we have a absolute value of Y and Z, and it's never be negative numbers because it's in the absolute value, yeah. Hech qachon anaqa chiqmaydi,
Yes, of course.
absolute anaqada modulda anaqa chiqmaydi, negativ son chiqmaydi, manfiy son. Shuning uchun anaqa bo'ladi, continuous bo'ladi.
To'g'ri.
And of course,
Nol chiqadimi?
anaqamiz kelgan domainimiz 0 bo'lmaganligi uchun continuous bo'laveradida. 0 to'g'ri kelmayapti-yu. Demak, continuous bo'laveradi. Denominator.
Demak, y z 0 bo'lmasa, continuous bo'ladi, to'g'rimi? Shu domainidami, uni aytib ketsak bo'laveradi. Continuous
Y and Z.
Y is not equal to 0.
Not equal
Z
0 or Z.
Is not equal to 0. And the last one, h of x, y, z equals to 1 over z minus square root of x squared plus y squared. So in this case,
continues when the z not equal to, yeah, it's continuous when the z not equal to 0.
Z not equal to 0? No.
Aslida z 0 ga to'g'ri kelmasa bo'lishi mumkin, chunki
bunday ishlaymiz-da, mahrajini 0 ga tengmas deb ishlaymiz. So z is not equal to which number? Z 0 bo'lishi mumkin. Z o'rniga 0 qo'ydik. X o'rniga 1, y o'rniga 2. Yuz ostida 5 bo'lyapti, bo'lishi mumkin. Z bunga teng bo'lmasligi kerak.
Asli 0 ga unga teng bo'lishi kerak. Chunki masalan, mononi ichidan pozitiv son chiqishi mumkin. Agar z 0 mahrajimiz 0 ga teng bo'lishi kerak emas. Keyin masalan buni z da hozir to'g'ri. Tushundim.
Z 0 ga teng emas.
Adashtirib
ketdingiz menimcha. Mahraj 0 ga teng to'g'ri bo'ladi.
Asliga adashib ketdi. Mahrajimiz 0 ga teng bo'lishi kerak emas.
Shunda uzluksiz bo'ladi.
Men yaxshi z da adashib ketibman. Chunki z da 0 ga teng emas deganim minus chiqsa bo'laveradi-yu anaqadan. Mahrajda minus bo'lsa ham continuous bo'lishi mumkin. Men просто asli z da bo'lmaydi deb o'ylabman. Hozir. Adashib ketibman.
To'g'ri. Minus bo'lishi mumkin mahrajda, to'g'ri. So I think that's all for today. Exercises on our practice lesson, and you may find some more exercises in the book.
Okay.
Thomas Calculus. There are a lot of books like 14.2, theme 14.2, page 810. Page 810. There are, I think, 80 exercises. There are 80 exercises there.
Okay.
I think it's okay if you can solve like 60 of them or 40 of them if you have time. And if you have any questions about solving these exercises, try to ask from me. I'll try to answer.
Okay.
So good luck. See you next time. And later I will upload the homework assignment to the Moodle platform. And I also uploaded a
Okay.
homework assignment for the first practice and lecture. And for the second practice and lecture, I'll try to upload. So do not forget to do your homework assignments.
Okay.
Okay,
Okay, I
good
got
luck.
it. I think I did first lecture's homework. I think I did.
Uh, I don't know. I didn't check it yet because I didn't have a time for that. Now I'll try to update
Okay.
it soon. Okay. Good
Okay.
luck.
Thank you, teacher.